Hello class, my name is Leia and I'm going to be demonstrating how to solve 3.1. So we were given an image like this with 12 pentominoes, 5 units each, and the question was asking how can we rearrange just 3 pentominoes in a rectangle, 4 in a rectangle, 5 in a rectangle, and then to get all 12 in the largest rectangle we can get it in. So first, I wanted us to visually see that there are exactly 5 units within one pentomino. So I drew lines to represent this. And then we're going to form our first rectangle using 3 pentominoes. I have to figure out which shape is going to correctly match with the other shapes in order to form a rectangle, a 4-sided figure. In order to do so, we're going to start by realizing that the area is 15 units squared. And how I found this is knowing my 5 units per pentomino, multiply that by the desired amount of pentomino you want to make your rectangle, and you'll get 15 units squared. Okay, next we're going to determine the rectangle's width and length. So are we making a skinny rectangle, a fat square? What is this going to really look like? We have to know our area in order to determine this step as we're visualizing which pieces go together. And so I recognize that 15 has 2 sets of factors. We got 5, not 15 times 3. That should be a 5. 5 times 3 and 1 times 15. Then we get to decide between the two, 5 times 3 or 1 times 15. Well, if we're looking at our shapes here, we only have one group of 5 that goes straight down, so it has a length of 1, a width of 5 units, and we'd have to have 3 of those exact figures, so that's not possible. So we're going to find 3 different combinations, making up a 3 by 5 unit rectangle like we have right here. Next, let's see if we can use 4 pentominoes in the form of a rectangle with its total area being 20 units squared because, again, 5 units per pentomino. Our desired number multiplied by our desired number of pentominoes to get our area. Units squared is 20, so 20 can be made up of the length 1 unit by a width of 20 units, or 5 units by 4 unit rectangle. It's going to be more realistic again to create a 4 by 5 rectangle. As you can see here, I manipulated, which means moved around exactly 4 different pentominoes to form a 5 by 4 rectangle. Now, let's see if we can draw 5 pentominoes in the form of a rectangle, recognizing that 5 units are multiplied by our desired number of pentominoes, getting us 25 units squared for the total area. And again, we do not have the shapes to be able to form a length 1 width 25 unit rectangle, but we can do a 5 by 5, recognizing that 5 times 5 equals 25. Those are its factors, and so that is what I did below using 5 pentominoes. Now, when we're asked to think about creating a rectangle using all 12 of our pentominoes, we're going to use the following steps like we have been doing. 12 pentominoes times 5 units per pentomino is going to get us 60 units squared. So we can go about this in different ways because 60 has different factors. We could multiply 1 by 60 and get 60. We can do a 5 by 12 rectangle and get 60 units squared, or we can do a 6 by 10 rectangle and get our area of 60 units squared. Now, recognize, knowing about area, when we get the maximum area, it's going to be more realistic to make this look as much as we can as a square, because in a square we have a width and length that are equivalent to each other, and it's more easy to manipulate these pieces to fit better together because of how they are shaped very oddly. And so I believe if you choose 6 by 10, since that is closer together in number than a 12 by 5 unit rectangle, you're going to have more area with a 6 by 10, forming all those parts together. Okay, thank you.